Welcome to the Future Pulse podcast, where we dive into the world of innovation and technology. My name is Melica, and I'm the founder and director of SkillTalks, which is a global tech recruitment company specializing within AI in infrastructure and data centers. So today I have with me AJ Meyer. It's an absolute pleasure to have you on here.
Great to be here. Thanks for having me.
So you're the CEO at Pickle Robot, aren't you? So
That's
it'd be
me.
great if you can tell our audience a bit more about your background and what got you to where you are today.
Sure. So Pickle Robot is a robotics company here in Boston, Massachusetts, and we make robots that unload trucks in warehouses along the supply chain. And my background was that I came up here to go to MIT in '05, and I was studying kind of a niche topic at the time, which was the intersection of machine learning and AI and robotics. And over time, that has become. It was very academic 20 years ago, and it's just been exciting to work in a field that has made progress every year that I've been in it. And finally, we can deliver products to customers based on that technology for the first time.
Amazing. And what is it that you are building and what is the problem you're actually trying to solve?
Yeah. Well, so the problem that we're trying to solve is how to actually make robots based on physical AI that work for customers. So our first product is a robot that unloads trucks, but really what we're trying to do is build a methodology for creating robots that can do all kinds of tasks that customers need, particularly the kinds that we call human-like, where they have to be dexterous and use their hands, they have to be mobile and move around, they have to work autonomously. But physical AI is technology that is only just barely starting to be market ready, and Pickle's kind of at the frontier of this category of products to get something to actually work. Because as I said, it's been academic for many years. Uh,
It's interesting you say that because I think like since last year, I've probably heard that buzzword quite a bit now. Didn't hear
sure,
it a few years ago, physical AI. So it's suddenly
there's a good
everywhere.
reason for that.
Yeah. So when you use that term, what does it actually mean in practice for anyone that doesn't know?
Yeah, so the term AI has been around since the 1940s, and it's
Oh,
changed
wow.
its meaning every decade depending on what was going on in academia at the time. At some point AI meant playing chess, and before that maybe it meant rule-based expert systems, and these days it means ChatGPT, I guess. And when we started Pickle, we were having the hardest time telling people that we made a robot, and that could mean anything to anybody. They're thinking C3PO, or they're thinking a welding robot, or they're thinking a little pallet cart that drives around. And so we kind of sat down in a conference room a few years ago and came up with this word physical AI to categorize things like self-driving cars, autonomous drones, robots like ours that could be part of a group that was all based on the same type of technology methods. And the term has taken off. And
So again, these things have been around. I mean, I think like a couple of years ago, we talked a lot about autonomous vehicles. Obviously, you heard of like Cruise and all those guys, but
yes.
now that is the term to use for essentially what that technology is.
And there's been plenty of other words, agents and embodied AI and machine learning and all kinds of things. Stochastic optimization. At some point, you just need the market to take up the word, and I guess it's just good luck that the one we landed on was the one that got taken up.
So it's essentially a new label in robotics, would you say?
Sure, but I think it really is just a label. The technology's been in development for decades and decades and decades. People have been trying to figure out how to get robots to think for themselves and use their hands and learn and be safe, since at least the 1960s and 70s. The first time I saw a robot do a backflip was in the late 90s. It wasn't based on physical AI, in my view, because it wasn't based on machine learning. You know, this field is just becoming to people's attention because it's starting to be commercialized. But in fact,
Mhm.
people have been working really hard on it for so long.
Yeah. So would you say that is the right mental model then? So the fact that it's often pictured as humanoid robotics then?
Yeah, I think humanoids are not the category center. I think it's a neat form factor. You'll see them in the market in the
Yeah.
future. They're not quite ready. They're a little bit too slow. But mostly a humanoid is about work doing fractional work. Like if you have a job that kind of fits and starts and you don't need it full time, a humanoid's a great choice because you want to be able to retask it. When you have full time jobs, which are typical in say like a production environment, like a warehouse or
Yeah.
a factory, you want a dedicated machine. Now, the physical AI part is kind of separate from the form factor. You could have self-driving cars, physical AI, a humanoid robot, a self-driving forklift. The key elements are: does it plan to achieve its goals? Does it learn? And is it safe? And the safety part is really the hard part that makes it different in the physical AI world versus the virtual AI world. There's also just a speed component. If you're trying to unload a truck and move your arm really fast so that you can keep up with the process, or if you're trying to drive a car and you're going 80 miles an hour down the road, the algorithms need to be really fast, which is
Yeah.
different from, say, like ChatGPT.
You've kind of touched up on this just now, but how should we sort of really think about it when you're comparing it to something like a purpose-built intelligence robot then?
I think the purpose built versus the humanoid really has to do with the physical form factor,
Yeah.
not the intelligence. And in fact, the AI stack that we use in our robot that we've been working on for 5 years has nothing to do with the form factor or the task, other than the fact that it's solving for arms and mobility and picking things up and putting them down and like doing tasks. But when you are a customer that has a particular need to do a job, you don't want to pay for stuff you don't need. So if you don't need legs, don't pay for them. If you don't need two
Mm.
arms, and one will do, don't pay for that. If you don't need 10 fingers, don't pay for that. And so at some point, it's just an economics question about special purpose form factors versus the kind of general humanoid.
Right. So, you mentioned robots or the ideation of robots. It's been around for a very long time, especially in areas like manufacturing. So, what do you think recently has changed to sort of make this current
Yeah.
moment different?
So a welding robot on a production line today at a Ford factory is going to look almost identical to what it was in the 1970s.
Yeah.
That is it may look the same because it's a big arm that moves around, but it's not making any decisions for itself. It's not agentic. It's not planning goals. It's not learning. And it's certainly not something we would call physical AI. And what that means is that if you watch them move, they always move the same way over and over again. They don't really have any intelligence in them at all. They're more like um, an automaton. They're just cycling through the motions. And so if I take a car door that's getting welded and I move it 1 inch to the left, all the welds are going to go in the wrong spot. So designing automation around that type of technology is what they call systems integration, and it's very expensive and very hard. If you can make the robots intelligent and agentic,
Yeah.
then suddenly, if the car door is in the wrong spot, the robot knows how to adjust, and suddenly it becomes very easy to integrate complex automated processes, which is really what this technology is going to bring to the market.
So, what do you think is kind of like tipped it for change then? Do you think it is the AI? Do you think it is the hardware? Do you even think it might be infrastructure, or is it actually the economics of the industry in general?
Well, I think that the AI absolutely is
Mm.
100% of why now. Like, for example, our first product is a robot that unloads trucks. We chose it because it's a very scalable problem that customers are like desperate to take up. We knew that if we could crack it, it would get taken up really quickly, in the
Yeah.
same way that like spreadsheets got taken up quickly when PCs first came out in the 1970s. Like everybody needs it. And so they needed it 10 years ago and they needed it 10 years before that. Like the demand for getting your trucks unloaded has been there the whole time, but it was impossible to solve. People have been trying to build automation for this task for decades, and we just needed robots that were smart enough to do the job before you could create a product around it. And that wasn't possible until just now. We didn't
Right.
start Pickle until self-driving cars achieved a certain level of maturity that the light bulb went off where we said, okay, if that can do that, then I think we can use those same algorithms in the warehouse.
So, with regards to the trucks and unloading of it, why
Yeah.
is that such an interesting and really important problem to solve right now?
Yeah. Well, first off, customers just really want it. If you're trying to get a business off the ground, particularly with frontier technology, you need to figure out how to bridge the gap from kind of research to demos to products. And at some point, the money for further development needs to come from a business that's generating cash flow as opposed to research funding. And
Yeah.
so we wanted to pick a problem that if you solved it, customers would take it up. And so unloading trucks is something that it's just ubiquitous. Like anytime you see a truck on the highway, just imagine it's coming to or going to or coming from a dock door where one of our robots is applicable. So every building along the supply chain has these doors and has this problem, and it's been impossible to automate until just now. I also think that it's a task that nobody wants to do, and it's, dull, dirty, and dangerous. And it's, in some buildings, the only unautomated piece. There's a lot of
True.
buildings with machinery in the middle that does everything, but the doors still require this like huge laborious manual effort. As soon as you automate them, suddenly the whole building is automated, and that to me is a phase change for a lot of customers where you go to a dark factory.
I mean, it does make it look like the physical AI piece may look easy putting that on there, but actually I think that actually poses quite a real challenge for how hard physical AI really could be in the real world. I mean, what do you think about
It's
that?
incredibly difficult. Just think for a
Yeah.
minute, like the Tesla FSD team. Like they've been working on self-driving cars since what, 2014? And the product is still not ready for full commercialization. Waymo still, after billions of dollars, doesn't generate cash flow from their operations.
Oh,
Physical AI is
really? Oh, wow.
incredibly, incredibly difficult. And the smartest people in the world have been throwing billions of dollars at trying to make a product work for more than a decade now. The reason why it's so hard is that in the real physical world, things need to be safe,
Yeah.
and we call it open world generalization. Like the number of edge cases you can encounter are infinite.
Yeah.
Even unloading a truck, the boxes can be wet, the truck can vibrate, there can be light coming in from the sides, there could be skis wrapped in bubble wrap, there could be a crack in the floor, like the temperature matter, like anything you could possibly look at can break your system. And so you need a technology that's smart enough that when you encounter these edge cases, you can reason around how to solve them, and then you can learn so that in the future you don't get stuck. And that's what physical AI is about.
Right. So, what's one shift in physical AI you think people are underestimating right now? I mean, I already kind of said it. I thought, oh, it could look a bit easy, but I guess it's not. So,
Yeah, people have been kind of getting this issue about what's hard for a computer to do wrong for decades.
yeah.
And it turns out that the things that are easy for computers, like playing chess, are really hard for people, and things that are easy for people, like walking, was really hard for computers. I think that the technology is really starting to work now, and the final piece of the puzzle really was a technology called diffusion. And or generative AI, they call it in other contexts. So, the exact same technology that lets you hallucinate a picture of a cat is the thing that you need to solve this open world generalization problem that exists in robotics and physical AI.
Right. So, last but not least, just for us to finish up. So, I always ask everyone this: where do you kind of see the landscape in 5 years' time? So, what do you think will feel obvious that it doesn't today?
Yeah. So I think that Pickle is a part of a very small set of, you know, robotic products with dexterous manipulation, and they're mobile, like human-like robots based on physical AI that are starting to actually work commercially. So in 5 years, I think you will see a bunch of them.
Yeah.
Automated forklifts and boxes that can pack robots that can pack orders, and drone deliveries. All that stuff is coming, and enough of it will be here by then that what will be really exciting in 5 years is stitching them together. Can I get my automated truck to talk to the robot that's going to unload it at the dock door, to talk to the forklift that's going to take the material away, and build these long processes of automation that is built entirely out of physical AI based products.
Interesting. Well, I hope, as Elon Musk said, that our work might be optional. I hope that doesn't apply to that industry
You,
anyway.
you know, I don't want to appreciate how scary it is to be, uncertain about how quickly what kind of technology is coming and what it's going to do in job displacement, because it is scary and uncertain and no one really knows. But
Yeah.
at the end of the day, we've seen this now in agentic coding, where the AIs have gotten really good at writing code. I have a bunch of very brilliant software developers on my team. I've been writing software my entire life. And, I write more software now with the agents than I ever did before. So they hardly took my job. And they actually, they actually made it made my job even more valuable. And I think that'll be true for physical AI as well.
Yeah, good insight. Anyway, well, thank you so much for jumping on the podcast with me.
Thank you so much.
Thank you.